Starting with the electrical service is a good initial step in the design process, particularly for larger projects. It establishes a foundation for the entire electrical distribution system and ensures the design adequately addresses the building's electrical demands. Next, considering power plants for heating, ventilation, and air conditioning units. Creating a separate power plant is advisable, especially for substantial heating, ventilation, and air conditioning systems, or when heating, ventilation, and air conditioning loads are significant. This approach helps to organize the design and guarantees that the heating, ventilation, and air conditioning equipment is supplied with dedicated power circuits. The number of drawing series needed is project dependent. For most residential projects, a series of 1 to 6 drawings may suffice. However, commercial and industrial projects might need additional series to cover all aspects of the electrical system. Drawing notes can be placed either directly within the drawings themselves or compiled in a separate notes list. Symbols are typically included in a key or legend provided in the drawings. Specifications are usually detailed in a separate specifications booklet or document. Although some project-specific notes or details can be included directly on the drawings for clarity or emphasis. Regarding mounting step-down transformers above ceilings, there are several factors to consider. Firstly, accessibility is crucial. Transformers need routine maintenance and inspections, which become difficult if they are not easily accessible. Secondly, heat dissipation is important. Transformers generate heat, and if they are mounted above ceilings, this heat can become trapped, leading to potential overheating and reduced efficiency. Thirdly, fire safety is a major concern. If a transformer malfunctions, it can create a fire hazard. Mounting transformers above the ceiling makes it more difficult to detect and extinguish any potential fires. Now let's delve deeper into each of these aspects. When establishing the electrical service, firstly, assess the building's total electrical load. This involves calculating the demand for lighting, receptacles, heating, ventilation, and air conditioning equipment, and any specialized machinery. Secondly, select an appropriate service voltage and amperage. This selection should align with the building's load requirements and the utility company's standards. Common service voltages include 120/240 volts for residential buildings and 208/120 volts or 480/277 volts for commercial and industrial buildings. Thirdly, determine the location of the service entrance. This location should be easily accessible for the utility company and should comply with local codes and regulations. Also, it should be protected from physical damage. When creating a separate power plan for heating, ventilation, and air conditioning units, firstly, identify all heating, ventilation, and air conditioning equipment. This includes air conditioners, heat pumps, furnaces, and ventilation fans. Secondly, determine the power requirements for each piece of equipment. This information is typically found in the equipment's nameplate or in the manufacturer's specifications. Thirdly, design dedicated circuits for each piece of equipment. This helps to prevent overloading of circuits and ensures that the heating, ventilation, and air conditioning equipment operates reliably. When organizing drawing series, firstly, establish a consistent numbering system. This makes it easier to locate specific drawings within the set. Secondly, group related drawings together. For example, all power plans could be included in one series and all lighting plans in another. Thirdly, use a clear and concise title for each drawing. This helps to identify the drawing's content at a glance. When placing drawing notes, firstly, use clear and concise language. The note should be easy to understand and should provide all necessary information. Secondly, place the notes in a location where they are easily visible. Avoid cluttering the drawings with too many notes. Thirdly, use a consistent format for all notes. This makes it easier to find and read the notes. When including symbols in a key or legend, firstly, use standard electrical symbols. This makes it easier for contractors and inspectors to understand the drawings. Secondly, provide a clear and concise description of each symbol. This helps to avoid confusion. Thirdly, place the key or legend in a prominent location on the drawings. When including specifications in a separate document, firstly, use a standardized format. This makes it easier to find specific information within the document. Secondly, include all relevant information. This includes the materials to be used, the installation methods to be followed, and the testing procedures to be performed. Thirdly, organize the specifications in a logical manner. This makes it easier to find the information you need. When considering transformer mounting, firstly, always prioritize safety. Ensure that the transformer is installed in accordance with all applicable codes and regulations. Secondly, provide adequate ventilation. Transformers generate heat and need to be properly ventilated to prevent overheating. Thirdly, consider the accessibility of the transformer. It should be easily accessible for maintenance and inspection. Now let's discuss some additional considerations for electrical design. Firstly, consider the impact of energy efficiency. Design the electrical system to minimize energy consumption and reduce operating costs. Secondly, consider the impact of sustainability. Use environmentally friendly materials and design the system to be as sustainable as possible. Thirdly, consider the impact of future expansion. Design the system to be easily expanded to accommodate future growth. Also, it is good to consider the National Electrical Code, also known as NEC, requirements. The NEC provides specific guidelines for electrical installations to ensure safety and compliance. Understanding and adhering to these requirements is crucial for any electrical design project. Some relevant NEC articles and tables include Article 220, which covers branch circuit feeder and service calculations. It provides methods for calculating the electrical loads of a building to determine the appropriate size of conductors and overcurrent protection devices. NEC Table 310.16, which provides the allowable ampacities of insulated conductors based on their size, insulation type, and ambient temperature. This table is used to select conductors that can safely carry the calculated electrical loads. NEC Article 450, which covers transformers. It provides requirements for transformer insulation, protection, and ventilation. NEC Article 430, which covers motors, motor circuits, and controllers. It provides requirements for motor sizing, overcurrent protection, and control circuits. Grounding and bonding are essential for electrical safety. Grounding provides a path for fault current to return to the source, which helps to protect people and equipment from electrical shock. Bonding connects all metal parts of the electrical system together to create a low impedance path for fault current. Surge protection is important to protect sensitive electronic equipment from voltage surges caused by lightning or other events. Surge protective devices, also known as SPD, should be installed at the service entrance and other strategic locations throughout the electrical system. Lighting design is an important aspect of electrical design. Proper lighting can improve visibility, enhance productivity, and create a more comfortable environment. Consider the type of lighting fixtures to be used, the light levels required, and the control system for the lighting. Power quality refers to the quality of the electrical power supplied to a building. Poor power quality can cause equipment malfunctions, reduce equipment life, and increase energy costs. Consider using power quality monitoring equipment to identify and address any power quality problems. Also, consider the voltage drop in conductors. Voltage drop occurs when electrical current flows through a conductor and causes a reduction in voltage. Excessive voltage drop can cause equipment to malfunction or operate inefficiently. It is important to select conductors that are large enough to minimize voltage drop. Short circuit and coordination studies are important to ensure the safety and reliability of the electrical system. A short circuit study calculates the magnitude of fault currents that can occur in the system. A coordination study ensures that overcurrent protection devices are properly coordinated to isolate faults and prevent unnecessary outages. Arc flash hazard analysis is important to protect workers from arc flash hazards. An arc flash is a dangerous electrical explosion that can cause serious burns and other injuries. An arc flash hazard analysis identifies the potential arc flash hazards in the electrical system and provides recommendations for mitigating these hazards. Cable tray and conduit systems are used to support and protect electrical conductors. Cable trays are open support systems that are typically used for large numbers of conductors. Conduits are enclosed raceways that provide physical protection for conductors. Consider the size and type of cable tray or conduit to be used based on the number and size of conductors to be supported. Also, consider the ambient temperature of the environment. High ambient temperatures can reduce the ampacity of conductors. It is important to select conductors that are rated for the maximum ambient temperature in the environment. Harmonics are distortions of the electrical waveform that can cause equipment malfunctions, reduce equipment life, and increase energy costs. Consider using harmonic filters to reduce harmonic distortion in the electrical system. Power factor correction is used to improve the efficiency of the electrical system. Power factor is a measure of how effectively electrical power is being used. A low power factor can cause increased energy costs and reduced equipment capacity. Power factor correction capacitors can be used to improve the power factor. Uninterruptible power supplies, also known as UPS, provide backup power in the event of a power outage. UPS systems are typically used to protect critical equipment such as computers, servers, and medical equipment. Emergency generators provide backup power for extended power outages. Emergency generators are typically used in hospitals, data centers, and other critical facilities. Ground fault protection is used to protect people and equipment from ground faults. A ground fault occurs when electrical current flows to ground through an unintended path. Ground fault protection devices, also known as GFCIs, can detect ground faults and interrupt the flow of current. Lighting protection systems are used to protect buildings and equipment from lightning strikes. Lightning protection systems consist of air terminals, conductors, and grounding electrodes. Fire alarm systems are used to detect and warn people of a fire. Fire alarm systems typically consist of smoke detectors, heat detectors, and manual pulse stations. Communication systems are used to transmit and receive information. Communication systems can include telephone systems, data networks, and public address systems. Security systems are used to protect buildings and equipment from theft and vandalism. Security systems can include burglar alarms, access control systems, and video surveillance systems. Consider the Americans with Disabilities Act, also known as ADA, requirements. The ADA requires that buildings be accessible to people with disabilities. This includes requirements for electrical outlets, lighting, and signage. Life safety systems are systems that are designed to protect people's lives in the event of an emergency. Life safety systems can include emergency lighting, fire alarm systems, and smoke control systems. Sustainable design is the practice of designing buildings and systems that minimize environmental impact. Sustainable design considerations can include energy efficiency, water conservation, and the use of environmentally friendly materials. Building automation systems are used to control and monitor building systems such as heating, ventilation, and air conditioning, lighting, and security. Building automation systems can improve energy efficiency, reduce operating costs, and improve occupant comfort. Also, consider the future trends in electrical design. These trends include the increasing use of renewable energy sources, the development of smart grids, and the growing demand for energy-efficient buildings. In conclusion, successful electrical design requires a comprehensive understanding of electrical principles, codes, and best practices. By considering all of the factors discussed above, you can create electrical systems that are safe, reliable, efficient, and sustainable. Keep learning and stay updated to improve your design skills, ensuring you deliver the best possible solutions for every project.